All right, class. Our last lesson we were subtracting with like denominators. Now we're going to talk about how we could subtract if our denominators are not alike. So the first one we're going to try is 8/12 subtract 1/2. 8/12 subtract 1/2. So now if you don't have a piece of paper and a pencil, go ahead and push pause and get a piece of paper and a pencil and write this with me. I want you to write what I write so you can kind of practice. So run and grab a piece of paper, push pause, and then go. Come on, go push pause, and then go. All right, okay, I hope you've got a piece of paper and a pencil. All right, so we have two different denominators. We know that we can't subtract two different denominators because we have to have all the pieces the same size. And if this one are 12th sizes and this is a half size, these are great big differences between pieces. A 12th is going to be even smaller than our little 1/10 piece right here. And a half is going to be great big. So you can't really subtract those because they're just not even. All right, so we've got to even these out. Now, in one of our former lessons, we renamed denominators by just switching and multiplying. So this we would multiply by 2, and this 2 we would multiply by 12, and we do it to the top and the bottom to get equivalent fractions, but that have the same denominator. Well, in this case, we could do that and then have, 24ths as our denominators for both of these. But there's actually a little easier way. If you have a number, this 2, for example, if you have a 2 that if you could times 2 by something and have it equal 12, then all you would have to do is change one of the number's denominators and they would both be the same, right? So you could keep this one as 12ths, and you could just change this one to make 12ths. So you would have to think, okay, I know that 2 times something equals 12. 2 times what was that number? 2 times 6 equals 12. And so whatever you do to the bottom, you have to do to the top, all right? So I could say 1 times 6 equals 6. So I basically just renamed 1/2 and made it 6/12. So now I have 8/12 and 6/12. They both have the same denominator. All right. Now, if say that 2 didn't go into 12, then I would have to multiply both of them and find the same common denominator again. But this way, I already know that 2 can times into something to make 12. And how did I know that? Well, I just said the multiples of 2. What are the multiples of 2? Well, multiples are skip counting, right? So I said 2, 4, 6, 8, 10, 12. I know we kind of did the little shortcut of, all right, if I have my multiples mountain and I put 12 on one side and I put 2 on the other side, I could skip count and go 2, 4, 6, 8, 10, 12. And on this side, I would say 12, 24. Oh, wait, hang on. I already have a 12 there, so I have 12 and 12. So I know, oh, I can keep my 12, and I can just change this 2 to that multiple of 2, which is 12. 2 times 6 is 12. So that's how you can kind of figure out, oh, do I need to change one or do I need to change both? That's how you can kind of figure it out. All right, so now we're ready to subtract. We can now subtract 8/12, subtract 6/12, and 8 subtract 6 is 2/12. 2/12. All right, and there I have my answer, 2/12. Okay, let's try another one. What if I have 9/10 and I want to subtract 2/5? All right, so now I can do the same thing here, and I can say, all right, well, we don't have the same denominators, and I need to make sure both of my denominators are the same. So I could just multiply both of them and say, okay, 5, I could multiply 10 times 5 over here and get 50, and I could do it to the same over here and do 10. But before I change both of them, I need to check and make sure that maybe I wouldn't have to change both of them. Maybe I only have to change one of them. So how can I figure that out? Well, I could use my Mighty Mountain trick of having mighty multiples and think, okay, I've got 10, 20, 30, I'm skip counting, right? 40, oh, and then I can go 5, 10, whoops, don't write a line there. 5, 10, 15, 20. Okay, so which ones do I have in common? Oh, wait, hang on. I've got 10 and 10. So I know that, hey, I can keep my 10 here and I can just change my 5 to a 10. So now I got to think 5 times something equals 10. So that my denominator is 10. 5, 10. Oh, that's 2 times. So 5 times 2 is 10. Whatever I do to the bottom, I have to do the same thing to the top. 2 times 2 is 4. So now I've just renamed my 2/5 into 4/10, and now I'm ready to subtract. I have 9/10, subtract 4/10, and that equals 9 subtract 4 is 5, and I'm keeping my denominator as tenths, 5/10. Okay, all right, so pretty simple. Now I want to try it with let's try it with another uncommon denominator. All right, my uncommon denominator is going to be 10 14ths, subtract 2 7ths. All right, well, let's see. I could multiply both of these and change both of them, but let's first check and see if there's something that's common between both of them and I wouldn't have to change both. I've got 14 and I have 7. So we have 7, 14. Oh, check that out. We didn't even have to go any farther. We have 14 and 14 here. So I know I can keep my 14 and just change my 7. So 7 times something is going to change to my 14 denominator. What could that be? Let's see. Let's count by 7s. 7, 14. 2 times. So 2 times 7 is 14. And whatever I do to the bottom, I have to do the same thing to the top. So 2 times 2 is 4. All right. Now I'm ready to subtract. And I have 10 subtract 4 is 4, 5, 6, 7, 8, 9, 10, 6. And I have 6/14 as my answer. All right, so now you know how to change your denominators. If they're not the same, you can change them to make them a common denominator in order to subtract. All right, good job.